Yes, hello everybody, and thank you. So I would like to welcome you to our webinar where we would like to present you the new approach of our FMEDA. So which is the result of our certification according to ISO 26262. Let me introduce myself first. I am Karin Ammon from PLATO in Dortmund in Germany. I'm responsible for consulting and plugins at PLATO. And I have joined the certification process regarding the methodological, it's a difficult word, methodological approach. And when we started the certification process, we thought that the TÜV would check the formulas and the correct calculations that are part of the FMEDA plugin. Yes, they did, but the real focus was on this flowchart. And we realized that we had not considered all the use cases that are shown here in this flowchart. We have now corrected that, and this flowchart, this is in the ISO 26262. And I will show you that in the moment that we can consider now, or can we offer now all these use cases described here. So what we will do, I have a short agenda. We will make an example directly in PLATO 1 in our software solution. We will define a safety item and a safety goal. We will define a part list. We will link the safety goals to the part functions via FunctionNet I will show. And then we will perform the FMEDA for the safety item and for all safety goals. This is one approach to make an FMEDA, not for one safety goal. So for all safety goals you have in the safety item. I will show how to use the failure distribution catalog and the safety mechanism catalog. And then at the end, we will assess the level of functional safety readiness of our FUSI item or FUSA item. So all the fault matrices for single point fault metric, latent fault metric, and the PMHF value will be calculated, and this we will extract per safety goal. So also the ISO 262 says you have to calculate this statistics per safety goal. And this is a very, very small example. And at the end, I will show you how to handle a lot of data. So how to import a part list with much of hardware elements inside and how to work with it. And now we will go to the example. Let's have a look. Can't stop it here. I will do this here. So PLATO 1, for this participants, they don't know PLATO 1. It's a web-based software. There is a database behind, and we are at home from coming from FMEA and engineering, and the PLATO 1 FMEDA is integrated in our FMEA engineering approach. That means it is integrated in the classic system function and failure analysis, you know, maybe from the FMEA. And so for this, I prepared a simple structure. I have defined a safety item. You can see this here. This safety item has three requirements, and the safety item has two functional blocks. And if I make the structure tree or the system structure, I can show here the complete one. It's a very, very simple example. The hardware functional block 1 has three supplying hardware parts. And the hardware function block 2 has only one supplying hardware part. So this is very, very simple to show how the FMEDA will work, and we will do the FMEDA later on for the hardware functional block 1. And in the second one, you need a FunctionNet. So we have three requirements here for the safety items, and I will link them now to requirements regarding to the functional block. So what is the question? To achieve or to get the requirement 1 for the safety item, I need the hardware requirement 1 and 2 from hardware functional block 1. And I need also the requirement 3 from another functional block. For the requirement 2, I just need hardware requirement 1, and for the other one, the hardware requirement 3. So what are we doing here? You see there we have functional function net we have defined also for the requirement 2 and the requirement 1. So this is the preparation for the FMEA and also for the FMEDA. Now I said the functional block has got 3 supplying hardware parts. I have to link them as well. So I will link all together and say link with all functions, so to get a complete function net. Going back to my safety item, the requirement 1, now we will make a big function net. We have a safety requirement, for example. It is supplied with 2 functional block or 3 functional block requirements, and also having 3 parts in our structure. And you see this is also green, everyone is green, so it's a classic function in our database. And now you have to assign a safety goal with an ASIL value. So if you assign one of this safety function or this requirements here with an ASIL value, it will be defined as a safety goal. For this, I have to switch to a requirements form. So it's here. So you see the same requirements here, and now I can define. So for example, the requirement 2 has got an ASIL value of C, the requirement 1, the requirement 2 gets an ASIL value of D, and the requirement 3, for example, an A. Going back to our 1 architect, how we will build up the structures, you can see now the safety requirements or the safety goals, they are assigned now with an ASIL value, and they are now in purple highlighted so that you know this is a safety goal in our data model. And for all these safety goals, we now will do an FMEDA. We will start an FMEDA for the hardware functional block 1. For this, we will go to our FMEDA form. It's not the requirements, it's in the functional safety. And you can see now here you have the subsystem elements. So these are the parts, the hardware parts of the functional block. And now in the beginning, you can see here's nothing inside the FMEDA form. You have to select the component type, which part of a capacitor you have, or which type of a capacitor. So I have just created one in our failure distribution catalog. I will show in a few minutes. And in the next, you have to define what kind of operating condition it is used here, in what kind of operating condition. And after this, the software takes a small time. And after this, you will see all the failures, and the failure distribution will be picked from a catalog and will be assigned here to our capacitor. And the first time it takes a moment, just wait. Maybe we can go for the next one. We have a resistant. We will also select a component type. No, we have to wait and we have to actualize. I hope it will work here. Yes, now we have it. I can stop. So you see here we have 1, 2, 3, 4 failure modes for a capacitor. We have a failure distribution, and later on we will also calculate the fit distribution. And we have all the safety goals that we have assigned on the top level to our hardware functional block 1. And the same for the resistant I will do. There we have two parts of operating condition. We will take the high stress one, and the same will be with other failure modes. Distribution will now be imported to our form. Let's wait for a second, and then I will show you where they are coming from. So how is the failure distribution catalog built? So it's now the same. You see, I have defined the same failure modes, but there is another failure distribution for this resistant. So how does it look? So there is a failure distribution behind a failure distribution catalog. There you can define the component types, the operation conditions, and the failure types you have, and the failure distribution you have for the failure types. There is a validator behind, for example, when I change here, for example, to the higher one. So this is not a sum of 100% per operating condition, then you will get a sign here. The sum of the failure distribution is too high. So I will put it back. It's 10. This catalog, there is an import mechanism behind so that you can import your specific import failure distribution catalogs you have. And also in the future, we will have some standards behind so that you can import failure distribution catalogs from other standards like Siemens and other IEC standards. So going back to our FMEDA. In the next part, now we can enter in the next step, a fit value. I will show you later how to import a lot of parts having calculated fits. But now for this example, we will make it manually. There's a fit value of 5 for our capacitor. And there is a fit value of 10 for our resistant, for example. And what you see now, the failure distribution will be calculated here, the fit distribution. So if we have a fit of 10 and there is a fit distribution for the drift 0.2 of 30%, the fit distribution of this fault is 3. So this is a very simple calculation. And in the next one, you have to decide, I will put this away, that you can see the complete form sheet now. You have to decide if the component, the resistant, is safety relevant or not. If I select, for example, here, I can go up. You are not safety related, nothing will happen. And here you can't do anything. You can't calculate or put anything here inside. If the part is safety related, you have to select this here. Now you can see your complete failure fraction now has been switched to the fit safe. So if you are safety related, but none of the safety goals is violated because we didn't check anything here. So you are safe and all the complete failure fraction is assigned as a fit safe. Now, when I now decide that this fault, the drift 0.2, will violate the requirement or the safety goal requirement 1, I can have a check mark here. And now you see the complete fit distribution. The 3 is now calculated to the fit single point fault because you don't have a safety mechanism. So this is a dangerous failure and the single point fault is 3 now. If you have a safety mechanism and with a diagnostic coverage, you can select this here. So there might be a safety mechanism 1. I have decided there's a diagnostic coverage for 99%. So the dangerous part of the fit distribution 3 is now calculated 3 via 0.0.1. It is 0.03. And the part which is safe, which will not violate your safety goal, this will be the 2.97. So these safety mechanisms, they are also part of a catalog. I will show here. You can define as many safety mechanisms as you want. You can assign them a number and a description. You can classify them as it is in the standard, and you have to define a diagnostic coverage for the single point fault and the multiple point fault, and you can make a note behind. Going back to the form. For example, for another failure, I can decide now this is a multiple point fault. So I will make a check mark here. So the fit safe will be removed, and it's a dangerous failure. There is a fit latent multiple point fault failure rate. For 3 now, this is the same. We have the fit distribution, and now this is a dangerous part of the failure. If you have a safety mechanism, it's the same catalog. You will have access here at the moment. There is a diagnostic coverage of 90%. The latent multiple point fault failure rate will be calculated. This is 0.1 from this fit distribution of 3. And there is the one you can detect. This is a 2.7 part of the failure of the fault. You can also combine all these things. You can say that there is a failure which is also single point fault and multiple point fault, having a safety mechanism here. So it's not possible to have a multiple point fault. If you have a single point fault, you need a residual fault. So now it's the same. So I can combine this all the way, and so I can fill step by step my FMEDA form. If you have a part which is used more than once, so you have to check this only once, and you mustn't go through the complete FMEDA form. At the end, you need an operation time. So what does it mean? So the fit values we have added here in the beginning, they are scaled to 1 million hour operating time. And sometimes you don't have this 1 million operating hours. So here you can add a 1 by yourself. And you need this to calculate the PMHF value at the end. So, and if you have a lot of entries here, you mustn't fill the operation time several times. You can use the mass update, for example. You can say, if I have no entry, I want to have what did I do this here? 10,000 hours add to all my parts. So this will be done then automatically, and it will be filled for the complete FMEDA. So our FMEDA is very, very simple. It's very short. And at the end, you will get some statistics for all your safety goals. So we have extracted the total failure rate, the sum of the residual and single point fault failure rate, the single point fault metric, the latent multiple point fault failure metric rate, the sum and the metric here, and the one you can detect for the multiple points. So it's also the sum and the PMHF value. So we have only a PMHF value for the requirement 1 because I always selected this here in my example for the calculations. So this is the extract from all the FMEDA you can do in one approach, and having the fault matrices for each safety goal. So going back to the idea that the normal world is not that simple that my example is. So I will show you now how to import a list of parts having also fit values in. So you can open the FMEDA where you want to import all the parts, and we need the options menu. And in the options menu, you have the possibility to import. And you see we have a general Excel import filter that we need, for example, to import a failure distribution catalog or a safety mechanism catalog. And we have a special import of part list for FMEDA. This is optimized to import a huge amount of data, a huge list of data. And I've prepared an example. There is a CSV file for FMEDA import. I will open it here now and we can start. It just take a little time, not that much. I don't know, I think I have 100 elements inside. We will see later how much it is. So it takes a short time. And now, so it's green now. You see here, now we have a new list of elements in our structure tree. And the FMEDA form has been updated. So these are all the elements I have imported in my FMEDA. They are new. I will close it here. And so this is the beginning, what we have filled in another example. And now you can see there are a lot of new elements inside. They are assigned with a component type and with an operating condition and with a fit value. What's not inside at the moment is the failure mode. So the idea is, or what will be available in the next step. So if this component type and the operating condition is also in the failure distribution catalog, then there will be an icon here at the top of the FMEDA where you can click on, and this icon will harmonize with the failure distribution catalog. So then all the failures, so what I do here now manually, they will be added automatically. I don't know why it's not coming. I didn't select this. Yes, so it will come. So this will be automatically imported. So at the moment, I have to do it by myself. So this was a short idea of the new FMEDA. And if I switch back to our PowerPoint presentation. So this is what we did. We had a safety related hardware element. So this were the system elements you have seen in the first column of our FMEDA form. If you decide it is safety related, then we were looking for our failure modes, and we had assigned safety goals to our failure modes, and per safety goal and per failure mode, we had done the decision, are you a single point fault? If no, then you go to the next one. Are you a multiple point fault? If yes, then you can perform also. Is it covered by a safety mechanism with a diagnostic coverage? Then you have the multiple point fault, the latent multiple point fault failure rate and the detected one. And also here, if the single point fault, is it covered with a safety mechanism? Then you will go to the residual fault, and this one, which is covered by the safety mechanism, goes to the fit safe.